Hi everybody, welcome in Austria. I'm Vincent Frate and I'm really happy to speak today at the RefComm, representing the Perner company, and we will speak today about processing non-standard feedstock related with the use of Perner bottom of the barrel technologies. Really short presentation of the Perner company. We are a private Austrian company with approx 500 people working in Austria, Germany, Russia, Ukraine, and we also have an office in Romania, offering a full range of engineering services. We are especially working in many refineries in the several countries where we have offices and with the petrochemical companies. But when you see here, we are active worldwide in approx 50 countries, especially with our bottom of the barrel technologies I want to present today, SDA and Biturox, bitumen blowing technology. And the last projects we started up were in Saudi Arabia, in Azerbaijan, in India, and so on and so on. So now, what do we understand about processing non-standard feedstocks? A standard feedstock is for the bitumen production vacuum residue. Even you can consider a big part of bitumen produced worldwide is just vacuum residue, straight run from the vacuum distillation used as bitumen because the specifications are okay. If this is not sufficient, if you process other crudes that are not producing bitumen directly, you can use our technology, for example, blowing it to the right properties. And here the standard feedstock is, as I said, vacuum residue with some fluxant if necessary, like HVGO or VGO. Oh, that's where it's easy and simple. We made many units defining that as a feedstock, and the total we sold over 50 licenses. And in some cases, we were using other feedstock, these non-standards. What, for example? One is the SDA Bottoms, SDA pitch. That's a really important alternative feedstock because you have it in many refineries and you have to use it somehow to do a valuable product. What's not easy now with the changes of the fuel oil specification due to IMO 2020. The second one is Hydrocracker Bottoms. Another possible that we already tested is a Visbroken residue. Stranded fuel oil, it's always a possibility, it's always from time to time available, or even cycle oil from the SCC. It's also manageable somehow in a limited amount. A really important thing to consider if you intend to produce bitumen out of these feedstocks or even out vacuum residue, you need a thermal stable product. Bitumen has properties related to the thermal stability, so the feedstock have to be somehow stable also, because if it's completely unstable, you will have an unstable product. So now let's start about 3 cases we studied in the past and that we can present you. Hydrocracker bottoms. We saw the properties of these bottoms are really depending on the process conditions, the catalyst used, the process crudes, of the licensor of the technology, because you have many licensors in this branch of refineries for this technology. So it can be really different from one case to the other. But we saw it can be quite a high percentage in the feedstock mix for the bitumen production. The limitation on one side will be on the quantity available, because the hydrocrackers bottoms are just a few percent of the input. Second possibility, Visbroken residue, Visbroken material. We saw it here. It can be a big problem because it's thermally unstable. So you have to limit it in any way in the mix for bitumen production to 20–30%, even less if it's really thermally unstable. Third possibility, stranded fuel oil. Stranded fuel oil, it's a really large definition. It's typically defined for a burning value and a viscosity at 180 or 380 centistokes max. So it's not really really deep specification. And as you know, when you work in a refinery, typically it's a mix of many streams, waste streams. So it has to be studied from case to case, and even inside the same refinery, it can be changing from day to day, depending which unit is running at which conditions. So it's a really difficult topic to consider. Now we will go to the most important alternative feedstock we know from the past is the pitch from the SDA unit. So here we will start. You see a typical configuration of a refinery, in this case with a loop plant. So you have the distillation SDA unit, where the residue is going here to the SDA unit. You don't have the pitch. You can blend it with extract from the loop plant if it's available, VGO or the lighter streams, VR or not, depending on the properties of all these. You have composition blending, where you optimize this mix to have the best possible starting point for the blowing unit, for the blowing process, the Bittrex process, our own process, to produce the quality bitumen. So you here have the combination of two bottom of the barrel technologies developed and designed together to get on one side the DAO to the further units and another finished product, the bitumen, with the proper quality. Now, as a statement, these two technologies are well known. They are used in many refineries. It's a proven solution, and the most important thing, you don't have any residue anymore, because you use the residue from one unit in the second one to produce a valuable product. So it's really important. And as I said before, with IMO 2020, with more respect on the environment, considering sulfur reduction and so on, it's getting always more important to avoid any waste in any case. Yeah. Second thing is the capex of these kind of units are not so high as other big units like a coker or a residue hydrocracker. So it's also really important if you have to invest in some technology, it's a good solution. And the third point, you have a compromise to do in the design of the SDA. You cannot run with a yield of 70% with pentane as a solvent and hope your pitch will be good to produce bitumen. Here you have to find the proper equilibrium between SDA and DAO amount you produce and the pitch that is still suitable for the bitumen production. That's really important. It has to be accepted, of course, by the client, because you cannot get the best amount of DAO available and still making something with the pitch. Then the pitch will just be hard, brittle, and it's impossible to use it for the bitumen production. So now let's start with the SDA. Of course, like you know, we start with the lab scale test typically in our laboratory in Leipzig. And starting with typically VR, you get the equilibrium between the DAO and the pitch, one stage with the proper solvent you consider, and it's a basis for our simulation model to go to the right properties of the two components, the DAO on one point and the pitch at the other one, as I said before. And all these parameters are based on the SARA analysis, the different components you have, saturates, aromatics, resins, and asphaltenes. You see a picture of our lab, as I say, in Leipzig in Germany. First, it was designed to use only propane as a solvent. In the meanwhile, we made some changes that we can also use butane, because we saw in some tests we made for a client that also using butane as a solvent can produce a pitch in the SDA that can be used for the bitumen production also. So we want to avoid any problems, that we are able to test propane and butane. And as I said before, if you use pentane or even C6, the pitch will with the highest probability not be suitable for the bitumen production. It's why we are only using C3 and C4 as a solvent, or a mix it's always a possibility also to use a mix of these two solvents. So now a little bit about the simulation model we are using for the SDA. Of course, it's the equation of state thermodynamics. As you know, the specialist about SDA here in the audience, they know that much better as I do. You use the TVP curve, the density of the Saras and the properties of the Sara fraction to feed the model. You define the BIPs between the different components. We are using a modified model of Coué and Prausnitz. Once the model meet the experimental data, then you have the right system and you can use your simulation model. And really important, what is different, what we had to this system is we have a special model for the pitch viscosity, because it does make us possible to predict and to define and to simulate a system that is producing an acceptable pitch for the bitumen production. Of course, this is based on the know-how of our specialists, the database we have of hundreds of tests for vacuum residue out of different crudes, different region in the world, different process data, different conditions for the tests. So, as I said, why are we using a simulation model? It's clear. You are reproducing the experimental data. You can calculate the yield of DAO, the solvent load, the properties, of course, and the impurities for these tests. You have also the properties of the pitch, as I said, what is really important. And then you can reduce the amount of tests with the time, when you get always more confident, when your models are always further developed and solver further developed, because tests are time consuming and of course also expensive. And time is always a topic in refineries, as you know. And then we can also then for studies, for first contact with clients, start to predict the SDA process with all the vacuum residue, or changing the temperature, the pressure, the solvent rates, or even the solvents. The parameters we consider important when, as you know, for the DAO are the metals, the CCR, and the nitrogen content. That's typical for the DAO, depending which plant is used downstream of the SDA different figures. What we consider really important, as I said before, are the properties of the pitch. And here you have figures we are using typically in penetration, softening point, and also paraffin content. But why paraffin content? For the specialists in bitumen in the audience, paraffin is the big enemy of bitumen. If you have high paraffin content, you will have a bad bitumen. The properties are terrible. So you have to limit it somehow. We saw in the past, now in the test we made a few years ago for a new client, and we hope that we will get the project soon, that it's a really good combination. This SDA plus Bittrex technology is a really good combination to produce quality bitumen out of a VR with really waxy. You cannot blow it directly because it's so waxy, you will not have proper bitumen. By using an SDA, taking the paraffin out of the pitch, because it's going to the DAO, is the light components, you will be able to get the proper feedstock to produce bitumen out of it. And that's a really good application for many countries, especially in Africa, where they have really waxy crudes and they are in need of bitumen production in the region. So it could be really important to use this technology in many countries now in West Africa, where new crude oils have been discovered and new refineries are starting to become erected, where you can then produce bitumen and further develop the infrastructure, relying on the own production of bitumen, not on import from the US or from Europe most of the time. Really short information about bitumen itself. Bitumen is not bitumen. That's called, it's called asphalt in North America, and bitumen can be is really different from one part of the world to the others. Why? Because you don't have a worldwide standard for bitumen. You have even 3 big families of standards. The first one is based on penetration and softening points, like you have in Europe, in the Middle East, in the big part of Africa. The second one is based also penetration softening point, but the most important parameter is the viscosity, like you have in the well-known Indian standards, the VG grades or Australian standards. And the third one is the best standards you find is the one used in the US, in New Zealand. It has been introduced, it should be introduced in South Africa sooner or later, is the performance-based standard. So it's really linked to the performance of the bitumen, of the asphalt, of the binder in the road after construction. So it's giving you a really good idea how good your bitumen is. The problem for the producers, for the refineries, is the testing is much more expensive. It's much more time consuming. You get 1 day later if you were producing properly or not. So it's really difficult for refineries, of course, to run on such kind of grades. It's why it has not been used in many countries up to now. Indeed, for production of bitumen, the three parameters you're typically using are penetration, softening point, and viscosity. And even only viscosity can be measured online and monitored directly in the process plant out of the reactor to the tank, and can be in this case used for defining for changing the parameters of the Bittrex if necessary. So that's really good. This measurement unit of the viscosity we developed in the last years because we didn't get the proper instrument in the past from several suppliers. So we worked together with a supplier to develop a new product. And you can contact me anytime if you want to have more information about this viscosity measurement, even if you're already our client and you have our technology, our Bittrex technology. Now, the Bittrex technology, just to give you an idea what it is and which capacity we're speaking about when you say bitumen. We have the smallest unit we designed was 70,000 tons per annum, sorry, up to 1.2 million tons per annum. So really a big range of capacities, from one small reactor producing industrial grade bitumen up to two big reactors producing road grade bitumen for the road construction, but typically over 90% of the bitumen produced worldwide is used in the road construction. Now, when you speak about bitumen production and blowing, it's the most important parameter is the blowing curve that you can see here on the right side. Is the penetration against the softening point. If you speak about VDU, about physical separation, you have a straight run bitumen is this black line you can see, and then when you start to blow, is a blue or the other one with flux. You see you have a curve, it's going up to the right, and it's managing, you can manage to produce certain grades you will not reach only by vacuum distillation, and it's where the blowing technology is used and where the blowing technology is important. Now, a few words about the technology itself, what it is and how it is properly running. It's clearly a chemical conversion, it's not a physical separation as in vacuum distillation. A really important factor, we are using air as oxidizing agent, no chemical, no catalyst. So it means the OPEX are really low, and that's really important. We are creating new resins and asphaltenes that are not in the crude. So it means we can use crudes that are not so-called bitumen crudes to produce even bitumen out of the residue. So you have a flexible production out of a wider range of crudes and also out of many different feedstocks. As we saw before, you can see here, you have several components that can be used as a feedstock. We make pilot testing to define the best feed composition. Of course, on the technical side, but also on the commercial side, you should use as much possible as PDA and VR, but not too much extract of VGO, or if possible, as I said before, even some LCO as a fluxant, because it's there and it is much cheaper. It's not a valuable product. Then it's processed under specific pressure and temperature. Typically, the standard process parameters for the Bittrex units are 250 degrees Celsius and 2 bars overpressure to meet, at the end of the day, the right bitumen specification and properties has been defined from the beginning by the client. As I said before, depending on the region where the unit will be based or on the market your client intends to meet. Now, the core of the technology, of course, is the reactor. Really important, we have here a continuous reaction within the loop reactor, because typically for the bitumen producing units, you had batch process in the past and atmospheric conditions. Here we have overpressure and continuous. It means we have a much shorter blowing time. What's really important also through shorter blowing time, continuous operation, is the coke buildup is minimized, also because the air introduction in our case is really gentle but really efficient. The distribution of the temperature is really low. You have quite the same temperature over the complete reactor. It means you don't have dead zones, you don't have production of off-spec product in the reactor. It's running on a really stable operation. Really high yields, what's really important, it's why you can say it's a residue-free combination of technologies, because the yield is really high, and let's say the bitumen is like, it's 98% of your feedstock. And also really important, of course, you control all the parameters, you control the pressure, the temperature, you control the air introduction, you control the level, so everything is controlled and you have a really steady process. A little bit more details on the reactor itself. So you see in the middle you have an agitator, 3 stages agitator. Here is the level of vacuum residue of bitumen. The air is introduced on the bottom, big bubbles to avoid big strong reaction from the beginning. With the reaction going on, the bubbles are getting smaller, and you have a mixer to remix all the things. And then you have coalescence plates to get bigger bubbles again, and it's how you can manage to get a good temperature over the complete reactor. If necessary, as oxidation, it is an exothermic reaction. You can cool down the reactor with injection of water in the air pipes. Now, as I said, we make a lot of testing. It's why we offer also to our licensee a pilot plant that they can use, and they can run it at their facility, or we have one, of course, in Vienna where we can run tests for them. Having a reactor content is not too big, that we can work with small amount of material. It's discontinuous to have easier operation, and we can vary any kind of parameters, use a mix of any feedstock to produce any kind of products. So it's really good for R&D, for new products, for new feedstocks, and it's used by our clients. I will explain a little bit afterwards. Now, one of our selected reference using this combination of SDA and BBU. It's your case, it's IRPC in Thailand. The SDA unit is using the ROSE technology. This unit is running since over 20 years, producing a really good bitumen using the pitch from this reaction. So it's a good proof that it's running really well using some aromatic extract from the solvent extraction unit. And we are there producing AC6070 with this mix of vacuum residue, SDA pitch, and aromatic extract. So you see, it's possible, it's manageable, and what's really important on the economic approach, as I said before, you maximize always the SDA pitch, you minimize the aromatic extract, and as our client IRPC is having a known Bittrex pilot plant in their facility, they can also test the use of alternative cutter stocks, so to reduce even further the aromatic extract and use other feedstocks they have in their refinery. And here you see a picture of the unit that, as I said, is the model that's been made 25 years ago, but still the unit is running properly and they're really happy with our technology. Further, some references of SDA. The first one is H&R in Hamburg in Germany. Our colleague from EDL, part of Pernod Group, were working 2011. Or the last reference of SDA we have was in Nafta, for Nafta in Belarus. Here you see the extraction columns, and we assist on the start of 2019. Biturox, one of the last Bittrex units that's been started up in 2018 was for Sokar in Azerbaijan. It was the second Biturox unit for Sokar in Azerbaijan in the newer refinery, Ada Aliyev oil refinery. where we make an EPCS contract. We're responsible for quite a complete project. The construction was done by another company. And now in the courtesy of the car, I can show you a short video of the unit itself. Enjoy. So you can see here on the front side the reactor with the heat recovery and the thermal oil unit. Here you see really clearly the reactor with all the pipes around. The heat exchangers are on the back side here. Knockout drum here. Here you can see the process air compressors. Really important part, of course, because you need the process air for the oxidation. The buildings, the tanks for VR and for product, and the loading, the truck loading section. Now you can see the unit during the night, where it's also showing you more other details, perhaps, that you can see in that way. And here you see the big, of course, here the space, the layout is really splitted, but for a typical Bittrex unit, you don't need so much space as it is shown here. And the huge stack here on the left side, it is an existing stack that we didn't destroy. Decision by the client. Don't worry. Bittrex unit need a stack with 30 meters high. Here are some references of Bittrex units in Europe and CIS. Where you see 16 Bittrex units in this region producing road grade bitumen. In any case, approx 5.5 million tons per year in total. See here in Europe and here in Russia and countries around. Here in the Middle East, we licensed 10 Bittrex units up to now in 5 different countries, producing especially 60-70 road grade bitumen, capacity approx 4 million tons per year. And in India, where we had the most, where we are really working really good and having really good experience with our clients there, we sold 11 licenses. Producing mainly VG30, VG40, respecting the Indian standards based on viscosity with capacity of 3.6 million tons a year, would be moving on up to 5 to 6 millions in the next years. So we are really proud to work there with the big refineries to work on bitumen production for the region. So now, as a conclusion, really important. We speak here, you can use several non-standard feedstock to be processed to quality bitumen. That's possible. Why? How? Because we have this composition controlled bitumen for feedstock definition based on laboratory text, based on experience, to be able to produce bitumen quality. Really important, there are limits. We cannot use any kind of feedstocks. We cannot make from nothing great product. Anybody has to respect that. The proper design of the concrete system is necessary. As I said, you have to work together with other licensors. If you speak about Hydrocracker residues, if you speak about SDA pitch also, we are offering it together with our sister company, the solution, where we can work also with other SDA suppliers. That's not a problem for us. And as I said, this combination SDA and Biturox is the most cost-effective bottom of the barrel technology to convert vacuum residue to valuable product, quality bitumen, and DIO that can be processed further. So thank you a lot for your attention. If you have any questions, don't hesitate to contact me. You have here my phone number, my email address, and I will be really happy to speak with you. Thanks a lot and have a good day or a good night. Bye.